Welcome viewers. In this video we'll see the solved problem based on the sinusoidal response of RL circuit. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. Sinusoidal response of RL circuit, solved problem 1. So this is the circuit given. RL circuit. Resistance 50 ohm, inductance 0.5 Henry. It is excited by the exponential function 100 e power minus 50t. The switch T is available. I of t is the transient current. Now we'll see the statement of the problem. In the series RL circuit shown in the diagram, the applied voltage is E equal to 100 e power minus 50t. Find the first one, resulting current, initial rate of change of current. You need to find the two parameters. One is the current, resulting current, and initial rate of change of current. So when this first will apply in the time domain, the equation for the above is given based on the Kirchhoff's voltage law. The applied voltage E equal to resistive drop plus inductive drop. Voltage rise equal to voltage drop based on the KVL. So the voltage across the drop across resistor is R into I. Voltage drop across inductor is L di by dt, that is equal to E. So this is the equation based on time domain with the KVL. Now we'll apply the given values. We can substitute the given values. R equal to 50 ohm, L is 0.5 Henry, di by dt equal to applied voltage is 100 e power minus 50t. Now in order to find the resulting current, first we will take the Laplace transform, so that T domain will be converted into S domain. After simplification, we have to take the inverse Laplace, so that again we'll get the current in the T domain. So we'll take the Laplace on both the sides. So 50 is constant, Laplace of I is I of S, 0.5 is constant, Laplace transform of di by dt is S into I of S, right, minus 0.5 I0 plus. This 0.5 is nothing but the initial current, initial rate of change of current, that is equal to 100. 100 is constant. E power minus 50t is nothing but 1 divided by S plus A, right? 1 divided by S plus A equal to e power minus AT. A is nothing but here 50. So 100 divided by S plus 50. Now Laplace is taken on both the sides. So I0 plus is the initial current through the inductor that we assumed as 0. Right? This is the initial current not mentioned in the problem. So that we will take this is equal to 0. So after this 0, what we got? 50 I of S plus 0.5 S into I of S equal to 100 divided by S plus 50. Right? So we know that e power minus AT equal to 1 divided by S plus A. Based on that, it is the Laplace transform is taken. Here A is nothing but 50. So e power minus AT is 1 divided by S plus A. S plus 50. Right. Now we'll go for the further simplification. So here we'll take the I of S common. So that 50 plus 0.5 S equal to 100 divided by S plus 50. Bring this term in the denominator. So that I of S equal to 100 divided by S plus 50 into 0.5 S plus 50. Right. So now what we need is the S plus form. Standard form is S plus. Here 0.5 is there, so we will take the 0.5 outside. So that S plus 50 divided by 0.5. Right. 50 divided by 0.5 is nothing but 50 divided by 1 by 2. That is, this 2 will go to the numerator, so it becomes 100. So finally what we got, I of S equal to 200. This 100 divided by 0.5 become 200. S plus 50 into S plus 100. 50 divided by 0.5 become 100. So we'll take this equation 1. Now by using the partial fraction, we'll split the terms. Then only we can take the inverse Laplace. Now we'll see how to take the partial fraction technique. Now we'll take this equation number 1. So now by partial expression technique, the above equation can be expressed as I of S equal to K1 divided by S plus 50. plus k2 divided by s plus 100. So now this term is splitted. Now we can easily take the inverse Laplace of this expression. But we need to find the value of k1 and k2. The equation 1, 200 divided by s plus 50 into s plus 100, that is written like this. That's so that this equation 1 is equal to this partial fraction technique, k1 divided by s plus 50 plus k2 divided by s plus 100. Now we'll take the LCM. We'll take this LCM here. Here only one term available. So it is multiplied by s plus 100. This term is multiplied by s plus 50. So these two terms available on both the sides. So got cancelled. So finally what we have, 200 equal to k1 into s plus 100 plus k2 into s plus 50. Now we need to find the value of k1 and k2. We need to substitute the value of s such that we need to find k1 and k2. First select s equal to minus 100. So if we put s equal to minus 100, what happened? This term become 0. So we can easily calculate k2. Similarly, s equal to minus 50. If we substitute here s equal to minus 50, this term becomes 0, so that we can easily calculate k1. So we need to decide the s value such that any one term got cancelled. So here 100 is there, so we are substituting minus 100. Here 50 is there, so we are substituting minus 50. First we will put s equal to minus 100. So that 200 equal to k1 into minus 100 plus 100 plus k2 into minus 100 plus 50. So this term becomes 0. So 200 equal to 0 plus minus 50 into k2. That is 200 equal to minus 50 k2. So k2 equal to 200 divided by 50. Minus 200 by 50. So k2 equal to minus 4. Right. Similarly, we can go for s equal to 50 minus 50. So 200 equal to k1 into minus 50 plus 100 plus k2 minus 50 plus 50. So this term become 0. So 200 equal to 50 k1. So k1 equal to 200 by 50. K1 equal to 4. Right. So there k2 equal to minus 4. K1 equal to plus 4. Now we got the both the value k1 and k2, so that we can write the equation 1 as k1 divided by s plus 50 plus k2 divided by s plus 100 can be written as k1 equal to 4, k2 equal to minus 4. Right. Now we'll take the Laplace inverse, take inverse Laplace on both the sides. So we are using the same formula, e power minus at equal to 1 divided by s plus a. Right. Here minus mean here plus. So 4 is constant, 1 divided by s plus a. A is 50. So e power minus 50t. Minus 4 is constant, e power 1 divided by s plus a. This is 100. So e power minus 100t. Right. So this is a is 50 first term. Second term a is 100. Based on that 4 e power minus 50t minus 4 e power minus 100t. Based on this expression inverse Laplace. Now we calculated the current in resultant current of the circuit. Now we'll go to the second part. The rate of change of current that can be done by di by dt. Initial rate of change of current means di by dt at t equal to 0. Initially the current is 0. So we have to differentiate the current equation for current with respect to t and substitute t equal to 0, so that we can find initial rate of change of current. Right. So d by dt of this expression for current, e power minus 50t minus 4 e power minus 100t, what we got in the first division. This is the expression for current I of t. Now we have to differentiate. 4 is constant, e power minus 50t is nothing but minus 50 into e power minus 50t. Right. So the differentiation of e of x is nothing but x e power x. So this is the basic formula for differentiation of e of x. Right. So this x will come in the front side. So minus 50 into e power minus 50 into t. So minus 4 is constant. Differentiation of e power minus 100t is minus 100 into e power minus 100t. Right. So 4 into minus 50, minus 200 e power minus 50t. So here minus, here also minus is there. We don't plus 4 into 100, 400 e power minus 100t. So this is the differentiation of the current equation. Now we need to substitute t equal to 0. So that is the initial rate of current. Here for the t value we need to substitute 0. So minus 200 e power 0 plus 400 e power 0. We know that e power 0 is 1, value is 1. So minus 200 plus 400. So totally it is 200 ampere per second. So initial rate of change of current is 200 ampere per second. So in this video we discussed the solved problem based on the RC circuit excited by the exponential function, sinusoidal function or exponential function. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.